Hey everybody, it's Mr. Carr again. Today we're going to be talking about 2A Day 3, solving equations with applications now. All right. So when we look at these, remember what we've covered so far is we've looked at multi-step equations. All right. We're going to apply those now in a variety of different problems. First thing we got to make sure we clarify is how do we translate certain phrases into math expressions? Okay. So for example, for addition, we can say a couple things. We can say a number X plus 10. So plus is an addition word. Or we can say the sum of 3 and a number n. Okay, so number x plus 10 would look like this. X plus 10. The sum of 3 and a number n would just be the 3 plus n. Subtraction has a few words to it. We can say subtraction is the difference of 7 and a number a, and then 12 minus a number x. Okay, so the difference of 7 and number a, I'm going to put in that order. So we would do 7 minus a, 12 minus a number x. So I could do 12 minus x. Multiplication, we can have 5 times a number y, and the product. So the term for an answer to a multiplication problem is a product of 2 and a number n. So 5 times y, I could just write it as 5y. Product of 2 and n is 2n. Okay. Division, we can say the quotient of a number a and 6, and 8 divides into a number y. This gets a little bit tricky because I could say this in a couple ways. I could say divides by a number or divides into. So in this case, well, let me do quotient. Quotient of a number a and 6 would look like this. A divided by 6 or a over 6. We can write it as fractions. If I say 8 divides into a number, then I'm going to say y divided by 8. Okay. So 8 divides into a number y, I would say y divided by 8. That's another way of saying the same phrase. Y divided by 8. Okay, so that's where it comes up a lot. So we got sum, difference, product, quotient. Okay, so these are going to come up in a variety of ways. Just remember, these are the answers to our problems. Okay, so translating, we're going to practice that a little bit here. Translate the sentence into an equation and then solve. So we say this, there's one more key word here, and that's going to be is. In both of these cases, we have is in there. So remember, in an equation, it has to have an equal sign. Well, that's what is doing. That's my equal sign in both of these cases. Okay, so I'm going to say 14 less than. This one's also a little tricky. I wish it was in the chart. We say less than, I like to think of an example of, for if I say 5 is how much less than 8. So if I say that 5 is, or let me rephrase that. Okay, what number is 5 less than 8? Okay, if you think about that for a second, hopefully you came up with 3. And the reason I can do 3 is I do 8 minus 5 equals 3. 3 is 5 less than 8 is what I would say here. Well, when I look at that order, notice how I said 5 less than 8, my actual subtraction was switching that. I did 8 minus 5. That's what happens here. If I say 14 less than something, then I'm actually going to be subtracting by 14. Okay, now it's 14 less than 3/4 of a number. If I don't know my number, I like to pick variables for it. Okay, whatever you want. You can do X and Y and N, smiley face, whatever you want to make your variable. Okay, so in this case, I'm just going to call the number X. So 3/4 X. I'll put that a little bit closer here. Okay, 3/4 X. So we got minus 14. That's 14 less than 3/4 of a number. And I probably should have mentioned that too. Of a number is multiplication. Okay. There's a lot of words, and that's the kind of the limit of that chart that we covered. There is a lot of words that mean these things, but we're going to try to focus in on just a handful. Then we got is. Is, you see in a phrase like this, is going to be the equal sign. And then -8. So now find this number. Okay, and now we're just doing the same process we did in the previous. So we're going to add 14 to both sides. Okay, so I'm going to rewrite this over here. I've got 3/4 x equals a +6. Then I want to undo the 3/4. Now, normally if we have multiplication, we do division. Because it's a fraction, I'm going to make this easier on myself. I rather multiply by the reciprocal. So that those cancel out, and I'm going to be left with x now. When I look back here, multiplying this out, remember that's going to be 6/1. I can actually reduce this. Divide by 3 is 1, divide by 3 is 2. So 2 times 4 is going to give me 8. All right. 2, I think, is a little bit easier to set up, but we're going to go through it step by step. 3 times the sum, okay? So when I talk about 3 times the sum, that means I need to do addition before I do my multiplication. The easiest way to do that is going to be with doing parentheses here. I'm going to group them together. It's the sum of a number and 5. So the number I'll call x and 5. So again, 3 times the sum. So 3 times the sum is what I have. Is, there's my equal sign again, right there. 21. So find the number. Okay. Some of you might want to distribute this. That's totally fine. I prefer to just undo the steps right here. So for example, if x is being added by 5 and then multiplied, I'm going to start off with dividing by 3 so that x plus 5 is going to equal to 7. And then I'll subtract 5 over, and I'll write over here, I get x equals 2. Okay, that's our translations. We are looking for it and taking it. I like to just take it step by step. Okay, remember some key things. We got these things where like less than means subtraction, but flipping the order. We got of is going to be multiply, and is means equals. Okay. Some other applications. We can also do some word problems with our linear equations. So we'll start off with number 3 here. Went to the store. Kristen went to the store to buy school supplies. The equation, well, let me block in some of that. The equation that models what Kristen bought is given by 3.5n plus 0.39 p equals 15, where n is the number of notebooks and p is the number of pencils she bought. How many pencils can she buy if she buys 2 notebooks? Okay, so if I interpret this, if I read through, 2 notebooks is going to represent n. So I know part of this problem. I'm going to have 3.5 multiplied by 2 plus 0.39p equals 15. Okay. All right. So from there, so my order of operations, first thing I got to do is I got to multiply these together before I could do any solving. So I got 3.5 times 2 is going to give me 7. Okay, from there, then I'm going to do the same thing I always do, which is I'm doing the order of operations. So I'm going to get rid of the 7 first. And I'm going to rewrite over here. So 0.39p is equal to 15 minus 7, which is 8. Okay, and then my last step will be taking 0.39 divided into both sides. So that will give me the number of pencils we can get after getting the 2 notebooks. So I divide that out and I get, fun little decimal, I get 20.513. All right, so realistically, okay, here's the thing. We need to answer, whoa, hello, what's going on with my, there we go. That's weird. Let me highlight those again. I don't know why it froze up like that. Okay, I took the equation, right? I just replaced n equals 2. So I plug that in. So I went to here, right, in for n in this spot. Multiply that out, I get 7. And then I subtracted 7 at both sides. So I get 8 is equal to 0.39p. Then I can divide by 0.39 to both sides and I get this decimal number. But here's the thing, we got some real life going on here. We cannot buy 0.513 of a pencil. So normally we look at a number for rounding, we say, oh, let's round up because it's greater than point. Like if I look at this and I want to round the 20 here, I look at the 5 and that would tell me, oh, I go up to 21. The problem is, realistically, Kristen's not gonna be able to afford that, okay? She can't buy another pencil, okay? She's limited in this case. So we're actually gonna round this down. So realistically, she can only buy 20 pencils. Okay. For number 4, this is a fun little 2-step process here. If this is true, find 5a plus 13. So thanks to what I have here, I can actually solve for this a. We're going to go ahead and do our process. We're going to add 9 to both sides. It's going to give me 21 is equal to a negative 7a. Divide both sides by a negative 7, and I get a negative 3. Well, 5a plus 13 is a separate expression, but still uses the same variable a. So I'm going to use the same number, negative 3 here. So 5 times a negative 3 plus 13. So I got negative 15 plus 13, and I get an answer of negative 2. Okay, that's a nice little extension on that. It's just a 2-step process to make sure we understand that part. The selling price of a television in a retail store is $66 less than 3 times the wholesale price. The selling price of a television is $8.99. The equation that models the scenario is right here. Find the wholesale price of the television. This right here is a good process to help break this down. Okay, explain what the variable W represents. It doesn't directly say, okay, but you look back and it says 3 times the wholesale price, and in my equation I've got 3 times W. That's what W represents, the wholesale price. Okay, we look at the equation and we see what is being multiplied by 3 is the wholesale price, and that's 3 times W there. So write an equation. In this case, it's already given, but if I didn't have that, I should be able to actually interpret this part, okay, which we'll get to in the future. But so we got $8.99 equals 3W minus 66. And as a reminder, some of these come from the selling price is $8.99, okay. The selling price of a television in a retail store is $66 less than 3 times the wholesale price. So the selling price is 66 less than 3 times the wholesale price. All right, and now I can solve. So I do that. I'm going to go ahead and I'm going to just move this over a little bit. Whoops, hello, missed a part. There we go. So I'm going to do my solving now. I'm going to add 66 to both sides. So I got $8.99 plus 66 is going to give me $9.65. And then I'll divide both sides by 3. Okay, I get 321 point, let's go 67. Okay, in this case, I don't need a round. We can have a wholesale price that's in decimals because we're dealing with money. Okay, so if I go down here for the final step, answer the question in a complete sentence. Remember, the question said, find the wholesale price. So I'm allowed to do that. I don't want to go further with my decimals because that's not realistic. But in terms of money, I can go 2 decimal places like that. So the whole sale price of the TV is $321.67. All right, and there's my final answer. And that's how we like to end our word problems, by answering in context of the scenario. Okay. So this was a little bit longer, but that is it for 2A day 3. If you have any questions, please feel free to reach out. But as a reminder, real quick summary, we look for certain key phrases to help us understand how to translate sentences into how to represent sentences as math expressions. We can use those to help model scenarios like this, or we can model real life context problems, or we can do some extra little steps with these. All right. All right. You'll get plenty of opportunities to work with word problems throughout the year. Trust me. Okay. All right. That's it for today. Take care, everybody.